The concept of mutually exclusive or disjoint events can also be explained with a deck of cards. Consider the events A, drawing a black card, and B, drawing a heart. If only one card is drawn, the probability of both of these things happening is 0. This is the intersection of events A and B, or we would say the AND probability is 0. So anytime these two events can't happen in the same instance, that is a disjoint or mutually exclusive pair of events. To demonstrate this, let's start by just shading these events. So all the black cards would be this top row and this bottom row. We have the hearts here in the second row. So we can actually see that the intersection of these events, which we have in this symbol, is 0. So an intersection, when we visualize it, we should see some kind of overlap there. There should be some card where those intersect. So in this situation, these are disjoint. Now, if we change those events, now we have the events A, drawing a black card, B, drawing a 5, and shading these, we'll see that there's actually some overlap, and these two shaded regions will actually intersect. You can also see this with Venn diagrams. And what we're doing with the deck of cards is we're kind of turning it into a Venn diagram where every single element of the sample space is shown. So we see here there is an intersection. We have a non-zero intersection. The intersection, or the probability of A and B, is actually 2 out of 52. The intersection specifically is that top number. And so we'll see in formulas that the probability of A and B, or that intersection, is the number of counts of the sample space where A and B intersect. And so that's two cards. We've got the 5 of spades and the 5 of clubs meet both criteria. So not disjoint means not mutually exclusive. Disjoint means mutually exclusive. And these concepts are very different from independent versus dependent events.